Hi, my name is Sarah Blick, and I teach middle school mathematics in Seattle, Washington. My favorite feature of the Desmos online graphing calculator is regression, and here's how I use it. In my Algebra 1 classroom, I like to present my students with scatter plots of data. Here's an example. In this scatter plot, I have data from different cars, and on the x-axis, it shows the age of the cars in years, and on the y-axis, it shows the value of the cars in thousands of dollars. So I would present the scatter plot on Desmos to my students, and I would ask them, what do they notice? So they might say, I see that the values of the cars get lower as the ages of the cars increase. So they might see a decreasing relationship. So then I would show them how to use regression to find out what type of relationship best fits this data. So in Algebra 1, my students learn about linear functions, quadratic functions, and exponential functions. So let's learn how to do regression for all three types of functions. Let's start with linear regression. We want to see, do the data in my y column relate to the data in the x column in a linear function relationship? So the most common form of a linear function that we use is slope-intercept form. So I want to know, in my second row, I'm going to type in, does y1 relate to x1 in slope-intercept form? So to see if it relates, we use tilde. Tilde, instead of the equal sign, will help us use regression to see if it relates. So does y1 relate to m times x1 plus b? So Desmos will then automatically create a line of best fit in blue for our data points on the scatter plot. It'll calculate what the m and the b of that line is, the slope and the y-intercept, and it'll give us our correlation coefficient. So our correlation coefficient here is r is equal to negative 0.991, a very strong negative trend. So I might ask my students, does this make sense for our data? They might notice, well, our graph is going to show that when our car is just about under 11 years old, the value is 0. And then as the car gets older, the value is less than 0. And does it make sense that after 15 years, our car is worth negative $10,500? Does that make sense? It's a really good conversation that we can have. So we might think that linear regression wasn't the best for this real-world situation. So then maybe we can hide this for a bit and try another type of regression. Let's try quadratic regression. So we're going to see, does y1, using a tilde, relate to x1 in standard quadratic function form, or a times x1 squared plus b times x1 plus c, standard form of a quadratic function. And Desmos has created the quadratic regression, or the parabola of best fit, giving us the parameters and our r-squared value of 0.986. So again, a strong quadratic relationship. But again, my students might wonder, is this the most sense? It's still becoming negative after about 10 years. So does our car just completely valueless or have negative value after 10 years? And what happens, why is something happening when our car is negative years old? Does that make sense? So is this the best model? So then maybe we'll try exponential regression. So we can hide this and scroll down a little and say, does y1 relate to x1 in our standard exponential function, which would be a times b to the x1 power? And here we see our exponential function of best fit with an r-squared value of 0.943. Again, a strong relationship with the exponential regression. Not as strong as the others, but still very strong, and we can see how this exponential function fits our data. So again, my students might wonder, does this make the most sense? Well, here the value of the car is never going to hit 0, but will get less and less as time goes on. So this might make more sense than the others, but it might not be perfect. So this leads to some very rich conversations about which regression model best fits our data, and we have learned how to use the regression feature on Desmos. Thank you very much.